Okay, hello. Today I will be doing a walkthrough of the Pandora machine on HackTheBox. This one was rated as an easy machine. I personally thought the steps to get to user may have been more of a medium, but the privilege escalation to root was quite simple. Essentially, quick outline of the box itself. First of all, we find some credentials through the snmp service running on port 161. From there, we can log into the machine, find a web service running. Through some dynamic port forwarding, we can view that website locally. It is running a vulnerable version, which can be exploited to escalate privileges to the local administrator user. That's the hard part of the machine itself. From there, you can upload a reverse shell and get a shell back as a user mat. And then Matt is able to execute a binary on the machine, which has the SUID bit set and owned by root, so that binary can be executed as the root user. And we can see that this binary can be exploited using path manipulation to escalate privileges to root. So let's go through it. First of all, just get that IP down, 136. And start with a quick nmap scan. Let's just do all ports, verbose, and we can see that we've got two ports open on TCP straight away, port 22 and 80. Let's just have a look at the website while that finishes. Lovely, so we've got this play website. Play is an extension of panda.hackthebox, bringing network monitoring solutions to your doorstep. So you can just have a quick look, see what this website has. Alright, got some info, yep. Pricing plans, questions. This one looks interesting. Yes, play is an extension of panda.hackthebox. That's fine. Cool, so not much going on here. You can send us a message. Let's have a look. Just see what this does. I've already got my burp open here, so just turn on intercept and have a look. Alright, we can see it's just taking these values, sending them as get parameters. Yeah, so not much going on there. Let's have a look on this side here, and you can see those values are just get parameters, doesn't seem to be doing anything. Just have a look at the network tab, see the resources being loaded in, if there's anything interesting there, all CSS, basic JS files, some image files, some fonts. So pretty boring overall, doesn't look like there's much going on there. We do have this panda.hackthebox, so we can add that to our host file. You can see the nmap scan came back, it's just port 22 and 80 open on TCP. Let's do a full scan. The default scripts enumerate versions, and we'll let that run in the background there. I might just do 22 and 80 since we know those are the only two open. Let's go to host file and add our IP to the host file, so 10.10.11.136, and we've got panda.hackthebox. Let's go back and see if this does anything different here, if we've got any virtual hosting. It seems to be the exact same website. I'm going to run 2 bits of recon in the background. First of all, we're going to do just some basic gobuster on this side here, see if we can find anything there. And we'll also do some virtual host, virtual subdomain enumeration there. See if we can find any subdomains for panda.hackthebox. So, first of all, gobuster, in directory mode, URL, panda.hackthebox, we'll do, let's just do big.text, we've got index.html, let's see if we've got PHP, it is running on Apache but we don't have a PHP file available to us there. We'll put it in just in case in the text file and gobuster big.out, and let's see if we get anything back there. While that runs, we can do a basic subdomain brute force for vhost. So let's do gobuster vhost subdomain brute force. Let's have a look what the syntax is for this one. Dir mode, DNS mode, vhost mode is what we want here. Cool. We've got .com, word list. Cool. So let's see if we've got anything there. Okay. We want to do panda.hackthebox as our URL. I'm just going to use the seclist DNS subdomains, and let's do subdomain brute.out. Cool. Alright, let's see if we get any results back. Apologies for the coughing for that one there. Alright, to our gobuster, we can see that we've got our assets directory, we've got server status with the 403. So let's go back, have a look at assets. We've got our CSS, fonts, images, JS, CSS, yeah, so that's all pretty standard. Can have a look at this main.js. Nothing too interesting there. We've got our wow, but overall looking pretty boring. We've also got no results yet for our gobuster vhost. So at this point, I'm going to let that vhost run. But while we wait, let's have a look at UDP and see if we've got any UDP ports open. So we'll go back to nmap. We're going to specify that we want to have a look at the UDP ports. Let's just do the top 1,000 and have a look. Let's see if there's anything here, and we should specify our IP. Cool, so we'll start the UDP. Just a bit of a waiting game at the moment. Got nothing for vhost here. It's fine. Can have a look at burp for our website here. See if there's anything interesting in the comments of the web page. Let's have a look. We've got uideck.com. It's irrelevant to this site here. We've got our CSS files. Yep, all of what we were just looking at before. Cool. Some JavaScript at the end, but yeah, nothing interesting there. Let's go back to our UDP, see if we've got any ports open here. Hopefully this one doesn't take too long. While we wait, I might just pause the video because it's all the basic recon that I want to do so far. And then once it's finished, I will come back. Cool, okay. So for the purpose of the video, I did decide to just cancel the previous nmap and just show that port 161 is open on UDP on our host. We didn't get any results back from our vhost enumeration, so let's focus on our newly found port 161. What I'm going to do with this one is just do a full nmap scan against port 161 UDP. So let's have a look. 161, our IP and make it very verbose. One thing I do want to do is output it to nmap snmp. And we can have a look at what nmap shows there. We can use tools such as snmp walk or something similar to have a look at the contents that we can retrieve from that snmp service running. I just prefer to use nmap. If we can use nmap, then we may as well just use it. And we can see that nmap returns a lot of information from snmp. We can see version 3 is running and the public community string is in use. So let's have a look and see the information that nmap returned from that one. We can see basic default services here. Scrolling down, got systemd, time sync, and it looks like we do have some credentials being leaked. So we can see this host check binary executable is running on the host there, and it looks like from the parameters they're specifying the username Daniel and password Hotel Babylon 23. So let's take this information here and just make a note of that. So we've got Daniel and we've got Hotel Babylon 23, and I will just leave this host check here in case we want to revisit that binary at a later stage. Cool. So with that information, let's see if we can SSH in as Daniel and Hotel Babylon 23. Perfect, and we can see we are in the box. So let's have a look around. We've got our SSH. We're in here. Nothing for that one there. I won't worry about adding a public key in there, just because we've already got credentials. First of all, let's see what Daniel can execute as sudo. Daniel cannot execute anything as sudo on Pandora. That's fine. Let's have a look at the internal ports open here. So we've got 3306 indicating MySQL, 2280 and 53. So the only thing we didn't really get to see before was this MySQL service running. Hopefully we get to investigate that one a bit later. But let's have a look at psorgs. Have a look at the processes running here. So we've got our host check with user Daniel and password Hotel Babylon, so we can have a look at that. That one is running as root, but obviously using user Daniel. We've got some Apache services running here. Cool. Let's have a look at host check and see what this binary here is doing. So we can see Pandora FMS host check utility. Files will be saved to host check. So let's have a look. Cool, so we've got some information back from this service running here. Localhost.localdomain on this IP. Pandora FMS server version 7.0 NG 742. Might make a note of that as well. Cool. So let's have a look and see where this Pandora FMS server is, and have a look and see if we can excuse me, get access to it. Cool. Well, first of all, we know that Apache is running, so let's have a look at Apache 2, have a look at sites available, and we can see that we have this pandora.conf. So let's have a look at this one. You can see the server name pandora.panda.hackthebox. Let's curl that and see if we get a response. We don't get a response for that one there. We can see that the assigned user ID is Matt, so the server does appear to be running as Matt. We can see the document root var www Pandora, so let's see if we've got access to that one. We do. Okay, so we can see that these files all exist within Pandora console, and we want to get access to this web server. Let's go back to that host check file there. We can see that it's using this domain localhost.localdomain. Let's try and curl that and see if we've got access to that. And we do. We can see it's returning that index.html we saw previously, which is just redirecting to Pandora console. Cool. So I want to access this site locally on my browser. Obviously, I won't be able to just access localhost.localdomain without doing some sort of port forwarding. We want to set up this server here as a proxy. I want to proxy my traffic through the server so I can access this localhost.localdomain site from my machine itself, from my Kali instance. So the way that I'm going to do that is I'm just going to quit that session there and use dynamic port forwarding that we can see there, and open up port 1234. And what that will allow us to do is essentially all of the traffic that we will send from our local machine through port 1234 is going to be sent into the Pandora machine itself, and that way we'll be able to access localhost.localdomain from our Kali browser here. So we'll open that up. I want to have a look at the creds again. Perfect. So if we have a look at our local machine here, we can see that now port 1234 is open. Okay, so what we can do, as I just said before, is proxy our traffic through 1234 through a SOX5 proxy there, and we should be able to hit localhost.localdomain within our Kali browser. The easiest way that we can do this, well, there's two ways we can do it. Number one, we can set it up through burp. So we've already got our Foxy proxy configured here for burp. If you want to have a look at this, you can see that we've got our HTTP proxy for localhost on port 8080. Within burp, we can actually go to user options and set up a SOX proxy. So what we can do is set up our proxy on localhost on port 1234 and making sure we're also doing DNS lookups to ensure we can hit localhost.localdomain. If I refresh this now, we've got burp configured. So our traffic first will go through burp and then through our SOX proxy. So let's have a look at this. And voila, we can see that we do have access to localhost.localdomain, our Pandora FMS instance, through our browser here. Perfect. So that's the first step. That's very good to start there. I'm not going to worry about a gobuster or anything like that because we do have access to all the files. Pandora console. We can see that we do have access to that all there. One thing I will do immediately is have a look and see if there's any config files. Hopefully there's some credentials available. Include is a good place to start with that one there. Having a look through, we can see config.php, but that one is readable by Matt only, and we are only Daniel. Config.inc.php I'm assuming is the default one. Yeah, Pandora. There's default creds, we can see they've been commented out. They're not being used anyway, but doesn't seem to be the credentials used. We can just easily check by doing MySQL, user Pandora, and password Pandora, and we can see we get an access denied. Alright, so not much luck there. Cool. Well, let's move our focus onto the Pandora console itself then. We can take the credentials we found previously for Daniel and try them out for this service here. So I got Daniel and Hotel Babylon 23. Okay, and we get an interesting error that says the user can only use the API. Cool. So we can't log in, but we can use the API. So let's have a look and see what this Pandora FMS API looks like. We also want to take note of the version we found previously. I do want to turn off burp while I do that. Let's just turn this off for now while I'm doing some research, and we can turn it back on after. So we've got our external API, plenty docked for that one, which is good. We do want to take note of the version as well. So we've got Pandora 7.0 NG version 4.2. Let's just do a quick search for exploits for that one there. Alright, we've got command execution, G, multiple vulnerabilities. Alright, we do have a blog post for 7.4.2 specifically for critical code vulnerabilities explained. I might just have a look at that one. Before we dig into that, let's have a look at the API itself and see if we can get any information as Daniel. First of all, let's just have a look and see how this API works. So we've got include API.php. Let's have a look and just confirm that this exists. We do want to turn on our socks proxy while we do that. Cool. Okay, so we can see that the API does exist, but there is an auth error, so we'll need to provide our credentials somehow to that API. Let's have a look and see. We've got security here. We do have an API password itself. Otherwise, it looks like we can just provide the Pandora FMS username and password. Passwords are uncoded. Okay, so we don't have to encode them at all. So we've got an example here. It wants to use this example to get some plugins, turn type CSV, API pass, user and pass. I'm not going to worry about providing an API pass because we don't have any information as to what that could be, but I will do user Daniel and password is Hotel Babylon 23. Okay, so we can see that it does look like it worked, but this specific Daniel user doesn't have permission to have a look at the plugins. So let's have a look at the different stuff this API has here. View calls, that's fine, API functions. We can get some info, we can confirm the version using info is equal to version. Doesn't look like we need a username and password for that, but we'll leave it in just in case. Cool, so we've just confirmed that is the version of Pandora FMS running there. Let's have a look and see what else we can do. So we've got some tests, license. Not really interested in this stuff. I don't want to dig in straight away to what Pandora FMS can offer. I just want to exploit it. The immediate first idea that comes to my head is trying to escalate my privileges to someone that's more privileged. So let's have a look and see if this article mentions users, and it does. Alright, we can use the API to get a list of users. So let's use the syntax here to have a look at the users. Info version, replace with users. Now we can do CSV, we can also do JSON. I prefer a JSON output, it's cleaner for me. We don't want to search it up on Google. Let's take that back there. Users, JSON, lovely. Okay, so we've got our Daniel user, which we knew existed already. We can see that it isn't an admin. We've got meta console access is basic, it's fine. We have a Matt user. We do have passwords being leaked here. So we've got our Matt user with a password there. Let's just quickly run that through John with RockU and see if we get anything back there. Matt hash. We can see that Matt is also not an admin. We do have basic meta console access, just as Daniel has there. Doesn't look that exciting, but we also have our admin user, again another hash. Let's have a look at this one. We can see that John ran. We don't have any output from that one there. Let's do an admin hash. See if we get anything back there. We can see admin is in fact an admin. We've got our email, advanced access for the meta console. Okay, cool. So immediately I want to have a look at these Matt and admin users here and see if we can escalate our privileges to these users. Going back to John, we can see that we couldn't crack both our Matt hash and admin hash. We can also have a go with Hashcat. From previously doing the box, I was unable to crack those two hashes. So we're going to move on to that and have a look at this article. Now we know from our info is equal to version that we saw previously. This is running FMS 742, and we can see there are some critical code vulnerabilities that exist excuse me, within this version. So we've got Pandora FMS, we've got several vulnerabilities, we've got an SQL injection, file deserialization, remote file inclusion, and cross-site request forgery. If we have a look at the SQL injection CVE here, we can have a look for a proof of concept. I have to turn off our socks proxy when doing research here. Let's have a look. Don't have any for this CVE. Let's double quote that. Concept. I'm familiar with that slide there. Yeah. So it doesn't look like there's a proof of concept that is easily available. This article does mention that while it does have a technical explanation of how it works, it hasn't provided a proof of concept because of how severe the exploit is. So we will have to basically follow through this article and investigate how the exploit will work and figure out our own proof of concept. So let's have a look. First of all, let's just have a look at this video and see what we're going to try and achieve here. So we do have our Pandora console. We can see that we don't have a login available there. We've got Pandora. Okay, so previously we can see that after some request is made for this Pandora FMS graph, we can see we go back and are now an admin. So we're going to try and escalate our privileges to an admin. They have then uploaded a shell to the system, and we can see that we get a shell as Apache there. Okay, so let's follow this technical analysis let's see how it works and try and replicate that same proof of concept. Alright, so first of all they talk about the security mechanism. We can see that within the source code, user input is typically sanitized with the help of a custom function called IOSafeInput. So it's trying to strip certain characters. We can see the code there. Also got the get parameter, which uses IOSafeInput that is retrieved from get or post parameters. Such a wrapper function is often used to avoid developers have to worry about cleaning up the values. It's fine. So there's pitfalls, so usage of this function is optional. Still may lead to problems, that's fine. So let's have a look at that SQL injection. So they're talking about this chart generator of Pandora FMS. When accessing the chart generator, we can see that the authentication is checked. So let's have a look and see if we can access this side here. Going to turn our SOX proxy back on, and we're looking for include chart generator. Chart generator. Make sure this is on. Yes, it is. Make sure this is still connected. Lovely. And we get access is not granted, but it means it does exist, so that is good. Cool. So first of all, as we can see, it is checking our authentication. We haven't logged in as any user, and we can only use the credentials with an API, so it makes sense that we get an error back. Now we can see that this chart generator, the user input is fetched from the request superglobal, which contains get and post parameters as well as cookie values. So the latter is probably the reason why get parameter was not used here, so we don't have the sanitization being performed on this one here. And the user input request session ID is passed to the constructor of the class Pandora FMS user without any sanitization. So this is our injection point here, the session ID. Now our request variable here can actually, if we look up request with PHP, go turn off SOX proxy. We can do some research into how this super global variable works. So you can see we can collect values with this request variable using request fname, which is simply just a post variable. So it looks like we can use post or get parameters, and they will exist within this request super global. So what we should be able to do is actually provide session ID as a get parameter for this chart generator.php file. So let's have a look. Session ID is equal to A. We want to turn a SOX proxy back on. Access is not granted. That's fine. We can see with this article here that this parameter is not being sanitized at all. So let's have a look and see what happens with a single quote after. And we do get an SQL error back. All right, so immediately we can see that this is prone or vulnerable to SQL injection. We can also see the query it's trying to execute here. It's trying to select all from tsessions PHP, where the ID session is equal to the value being specified here, limit 1. Okay, so that's a good start there. Let's keep reading on this article here and seeing the rest of the vulnerability at play. So you can see this check login function is used to check if the login session variable is set and valid, and evaluates true if the user with the given session ID exists and the access is granted. So we can have a look at this code here. So we can see if it's an array and if it exists as PHP session ID variable, which was given the value of our session ID. So at this point it's this A and comma. So if that exists, that's true. Then we're going to set our session variable. And it's going to use this db get row filter function here within this user.php file. So you can see the user control parameter, which is this PHP session ID, is passed to that function. And this function uses a couple of internal functions that dynamically builds an SQL query based on the provided table name, which is this tsessionsphp, as we saw with our access denied SQL query here, and a condition supplied as an array. Now our condition is just our ID session is equal to the PHP session ID value. So that is this value here, and as we can see, ID session is equal to this value here. So it puts it straight into the SQL query, which leads to SQL injection. Alright, so we can execute it straight from there. So this SQL injection allows an attacker to malform the constructed SQL and thus the result set of the database query. So then we can actually control the data within info data in line 71 of user.php. So that doesn't make much sense to us now, that info data. But then the session decode is used to load the session data from info data and populate it into the current session in line 78. So essentially, what it looks like this is doing is this tsessions PHP table contains session information about users that have registered to this or have currently logged in to this application. And we're trying to manipulate this to impersonate or fake an admin session. So what we want to do is essentially return a fake session information from the table by injecting some custom SQL code. So any user can be impersonated, including an administrator, with full access privileges by loading its user ID. So I don't know what this info data is, but it looks like, because we're using, where was it before? We've got our session ID, we've got our ID session. So I'm assuming this data, since it's part of the info, is one of the column names returned from tsessions PHP. Because info here is a result of our database query, and ID session is another column name as part of this table. I'm assuming data is as well. So what this article is saying is we can essentially control the data within info data by injecting some custom SQL code and creating our own data itself. That's a lot right now, so let's first use sqlmap and have a look at the contents of this tsessions PHP table. So let's go to sqlmap. Let's specify our URL. One thing I want to do is actually set up proxychains so we can route all of our traffic through our Pandora box over here. Now I've already set this one up here, but what we want to do is use SOX5, localhost 1234, and as we explained before, this will allow us to route all of our traffic through this open port 1234, which will then forward it off to our Pandora box. So very easy to use. All we need to do is then specify proxy chains, sqlmap, URL is our local host here, session ID, we'll leave that as A. Make sure it's using the session ID parameter. I'm going to use batch to automate all the responses from sqlmap. From there, I want to use, well, first we'll have a look at databases. I'm not sure what the database name is called yet. Okay, it's just finding the injection. You can see that it's possibly vulnerable to cross-site scripting, which we're not really interested in. Does appear to be Boolean-based blind, error-based. It's going to try some union stuff. Lovely. So it's found 3 different types of SQL injections: error-based, Boolean-based, and time-based. And we do have a database name, Pandora. So let's specify that using D and have a look at the table, which was called tsessions.php. And let's dump the contents of that table. Quite a few sessions that it's loading here, but let's just have a look. All right, perfect. So, got a lot of information here. We've got our ID session as one of our column names, data, which we assumed before was another column name, and we also have last active, which we haven't seen in any of that code yet. I'm just going to take this table here, copy that off, and tsessions.php out. Alright, so we've got a local copy of that. So we can have a look. We've got a few sessions for Daniel already available here. We can see the ID session for there, last active. We do have one for Matt. So what we can do is, let's test how this application is working by taking the ID session value against Matt here. We can see from ID session, and actually specifying it within session ID. Cool, now we don't get a access denied response. So it does look like this session ID, we know it exists in the database, we've specified it. Now let's see if we can log in as Matt onto the application itself. And we're Matt. So what's happened here is it's taken our session ID, which was specified here, it's done our SQL query as we saw before, and checked to see if the ID session exists within the database, which it does. We took it straight from the database itself. And we can see from our article here that once it's done that, it then uses this session D code to load the session data from info data, which is this stuff here, and then populates it into the current session, which allows us to log in as Matt. Cool, so that's the first part. Let's go back and log in as Matt again. Lovely. I don't want to take a screenshot. I do want to have a look at my cookies. And we can see that we've got this other PHP session ID value. If I just replace that one directly here, that should also work. And it has. Cool. Now we can't do much with Matt. We had a look. Matt also had limited access to this portal, as we saw before. What we want to do is try and become the administrator. Now, unfortunately, we don't have an admin ID session, so it won't be as easy as just taking the ID session here and then tricking the application into logging us in. What we can do instead is essentially try and replicate this output. Now, from the query that we get from the error, we can actually see what is being returned. So what we can do with sqlmap, we can specify that SQL query and have a look at the contents of the output there. So let's do that. Let's go back to here. We want to do our SQL shell option. Lovely. So we get our SQL shell. Let's actually use that query that the application is using. So select all from tsessions.php, where ID session ID is equal to, let's replace that A, get rid of that last comma there. Let's replace that A with the session ID that we specified earlier for Matt. Limit 1. Lovely, and we can see that we get our 3 results back. We've got our int value here, our data, and our session ID. That int value was the last active. We can see that the database or the table itself specifies that this is an int of 11 characters in length. We have our ID session, characters are up to 52, and our data, which is simply just some text. Perfect. So the application is then using this information here to create a session for Matt, and then we can use that session to impersonate Matt in the application. Now what we want to do is instead return our own custom session information. So instead of letting the application fetch this information from the table itself, we can use a union attack to essentially specify our own ID session, last active, and data, which will impersonate the admin user. Now, one thing we are missing is this number for admin. We know that this user admin exists. We saw it before, so we can just replace this data value, this Matt bit, with admin. But we don't have a number. We can see that it appears that Matt is 4, Daniel is 6. I mean, in the middle of that, we can just guess that admin is 5, but there is a different admin API call that we can make here, which is get list all user. So let's do that. We can use list all user. Wasn't meant to do that, but it's okay. Let's take that, bring that back here. Is it localhost.localdomain? It was. So what we're going to do is get that API call for list all user. Localhost.localdomain, Pandora console API, list all user JSON. We don't have an API pass. We do have user Daniel and password, I think it was hotel 123. Okay, let's double check that was in fact the password. It was. Just taking some time to load. Lovely, and we do get some information back. Now we do have our admin user. We can see this ID 5. That seems good enough to me. It's a bit weird that Matt is 2 here, but we'll use 5 as it specifies there. If it doesn't work with 5, then essentially we can just brute force some numbers. It won't take that long because we can see there's only 3 users on the machine itself anyway. But let's create our own session information using a union attack. So if we go back to our SQL error here, so what we want to do is essentially modify this query that we see here, all right, where select all from tsessions PHP, where ID session is equal to some junk value limit 1. What we want to do is, we know our injection point is here. Let's make that clearer here. What we can do is add a union statement here to return, whatever from the database here, and then union that with our own value. Now we want to make sure that this first select query here doesn't return anything. We want to make sure the application uses our custom value, so we can just do dud here. All right, then we want to do union select, and we want to return the 3 values that we know are a part of tsessions PHP. So let's have a look at those. We can see the first value here is ID session, and this can be any value of up to 52 characters. So let's do select. We've got a custom ID session. All right, and we're going to use that session to replace the PHP session as part of this cookie here and impersonate an admin user. So union select, let's say Cooper Hacks. Okay. We've got our last active, which is an int of 11. So let's do 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Okay, there can be anything there. And we also have our data. And we have a data format that we know the table is using. Let's take the one for Matt, and we're going to replace this with something suitable for admin. So let's change that 4 to a 5 and the Matt to an admin. Okay. Now what we can do is, well, first of all, let's just try and see if that works. So let's save that query and have a look at it here. So we know our injection point is right here. So let's start with that, and we can leave this last comma out, as we know that the application is going to append that anyway. I'm not sure about the syntax of leaving a limit after a union. I don't know if it will allow that, but let's have a look and see what this does. So we've got our session ID is equal to dud, union select, Cooper Hacks 222 admin, and leaving out that last comma. Cool. So we don't get anything back. That's could be a good sign. We hope so anyway. So let's go over to our PHP session ID and replace that with Cooper Hacks and refresh this page. All right, let's just double check if that has not worked. And voila, look at that. We are now the admin user on Pandora FMS. All right, because what we've done here is provided our own custom session ID, a custom last visited, and modified this data to represent the admin user. And with that, we can replace PHP session ID with Cooper Hacks, or whatever you want to put over here, and become the admin user. So from there, what we can do is follow the video that the application outlined previously, or this blog post specifically here. And what we can do is upload some shell to the system. So we've done this part here. We've got our FMS graph. Let's just make sure that this is high quality so we can see that fine there. Play the video. It's because I've got my proxy on. Let's turn that off. Refresh this. And have a look at this video again here. Come on, there we go. Cool. So we've done this part, we've logged in, we've got the admin user, so let's see what we've got. Admin tools, extension manager, extension uploader. Looks like they've got a zip and uploaded that. And then they've gone to extensions, found their shell, and were able to execute code on the system. Alright, so first of all, I'm going to get the pentest monkey PHP reverse shell, always quite reliable. PHP reverse shell.php. Cool. So let's download that. Let's get our IP, which is 14.3. I'm going to use 4444. Lovely. And we have our PHP reverse shell. Let's move that to just shell.php, and let's zip that up into shell.zip, shell.php. Perfect. Let's turn our socks proxy back on, go back to our admin portal here, admin tools, extension manager, extension uploader, and excuse me, find our shell.zip and upload that. Extension uploaded successfully. We saw before in that video that the path was within extensions. So let's start our netcat listener on port 4444, and let's hit, let's save this in case we want that after. SQL inject. Lovely. And we had it on extensions. The zip was called shell, and we have shell.php. We can't seem to find it there. Let's have a look at that video. Pandora consoles, extensions, shell.php. To save any hassle, we do have a shell already on the system. So let's have a look if we can see it here. And it's just shell.php. There was no extra shell there. So let's get rid of that. Shell.php. I don't want it on Google. Just wait for that one to load there. Should hopefully hit it soon. Ooh. Don't know where that one came from. Want to get rid of that. And lovely. We can see that we're Matt. And we have a shell as Matt on the system. Let's upgrade our shell. Let's turn off our socks proxy first for that. We want to make sure Python is on the system. It is. I love this blog for upgrading my shells. So we've got Python. Alright, we're Matt, sty raw echo, fg reset, terminal type of screen, and we can export term is equal to xterm. From there we can go to Matt's home directory, and we can see that we now have user.txt. What I'm going to do straight away is just add my public key to authorize keys on the box, because I want to have a nice shell on the system. So let's get our public key here, add that to authorized keys, and then we should be able to SSH in as Matt at panda.hackerbox. Lovely. Let's exit out of this one, exit out of that, and we don't need to worry about that. I'm also going to exit out of this one here. We've got a persistent shell as Matt now, so we shouldn't need access to this Pandora FMS anymore. Lovely. First of all, sudo, we can see that we do need a password for Matt to execute anything as sudo. What I will do is just upload linpeas and have a look on the box itself. Upload it in my tools here. Just get my IP again. And we want to use 10.10.14.3 linpeas.sh. Lovely. So let's have a look at our linpeas output. I want to use T for that. And see what we get back. So we've got Matt, Generic groups, users, that's fine. And let's see. Sudo 1.8.31, which is potentially dangerous, but most likely patched. Some kernel stuff, that all looks fine. We've got some capabilities set for systemd. They don't seem to be out of place. Let's go through some socket files. Sockets listening. We've got our ports here. That's fine. We've got our conf files. We don't really care about the database anymore since we could have dumped anything anyway. The only thing potentially is maybe if we want to make changes to it. We've already had a look at those conf files before from Apache. We've got some passwords potentially specified there. We can have a look at those last. It's usually the last thing I like to do. Got some bash RC files that we can see. One thing that does immediately stick out is we've got this Pandora backup SUID binary here. We can see that it's owned by root, but it has a SUID bit set, and it can be executed by mat. So mat is able to execute this binary as root, which could definitely be potentially dangerous. Got some logs, some backups. Already had a look at those files there. See if there's any passwords. Doesn't seem to be. So our best bet is to have a look at that SUID binary. Let's have a look at the path for that one. The capabilities, where was it? Logs, it was before then. Here we go. Pandora backup. So let's have a look and see what this is doing. Okay, we've got all of our files from var/dub/dub Pandora. Backup successful and terminating the program. Let's go to the top of this one here. See if we've got any hint of what is going on. Quite a few files in this web server. There we go. Alright, immediately we can see that tar is being used. We've got a note that it's removing some leading slashes from the member names and from hard link target. So we can see the tar is being used. I want to look at the exact command being executed. So what I'm going to do is also get, what was my IP? 14.3. I'm also going to get pspy from my system here. I'm going to be lazy and get a new terminal happening here. Let's have a look at pspy. So let's run pspy as we execute that backup command again, and let's see what's happening here. So we can see a tar command is being executed. It does have our wildcard here, but one thing it does include with this wildcard is a path before it. Now this would potentially be dangerous and much easier to exploit if we didn't have the path behind the wildcard. If, say, the command first cd'd into a specific directory, the var/dub/dub Pandora console directory here, and then just had a wildcard by itself. But we can see that it does have the path behind it. One thing I am focusing on is that we have tar being executed, but not using the absolute path here. Because we are executing this binary as root, but using the SUID bit, when the binary is executed, it is still going to use our local users, so mat's path environment variable. If we have a look at the value of our path variable, it's going to find tar through one of these variables here. However, we can edit that to whatever we want as mat. And because we're still executing this, the binary here, this Pandora backup binary as mat, but tar is being executed as root, the system will actually follow mat's path to find tar, but then execute tar as root. So what we can do is essentially append the temp directory to the start of our path environment variable here, create a new custom tar binary with whatever code we want, and then when we run this Pandora backup binary, it will be run as root, and it will still use mat's path environment variable to locate tar, but then run tar as root. And that will allow us to escalate our privileges. So let's first go to temp. Let's export path is equal to temp, followed by whatever's currently in the path. We can echo that to make sure it worked, which it did. Now what we can do is create a new tar file, which is just going to execute bash. I'm using the -p option. If we have a look at what the -p option does here, it essentially just maintains privileges. Bash-p option Linux. I don't want to give a wrong explanation, so let's just look it up on line here. This is going to take a while. Let's do man bash grep -p. What have we got? -p. Hopefully I haven't already passed it. I think I have. Let's go to the top again. Let's have a look. Standard input. Let's double quote this. Here we go. So it says the P option, let's bash keep the effective user ID it's launched with, which will be root, okay, because we're executing this tar binary as root. So essentially we want to maintain that the root user is the one executing bash here. So if we go back, we can see that our tar binary has been created. We want to make sure that that is executable. Okay, and what we're going to do is execute usr bin Pandora backup, and we can see that we are now root. So if we go into the root directory and cat root.txt, we can see that we are now root on the system. So that's the video for today. Hopefully that all made sense somewhat. I'll see you in the next one. Thanks.